All right, so you're watching this video because you missed the group lesson for the flame test, and we're talking about the atom spectra. Now, if you were here on the lesson and you still want to watch it, that's fine. This is not going to hurt you. It just kind of goes into the same things that we talked about in class. Now, we're going to start with just looking at the periodic table that you see in front of you. That periodic table shows all of the elements in their spectras. Their spectras are kind of like their fingerprints. So if you look at every element, no two elements have the same spectra, just like humans don't have the same fingerprint. And we're going to get into what are spectras and how they occur and what we would see, because we actually can't physically see those with our eyes. Now, because of the capabilities of my computer and the taping, I would stop it at this point and I would watch the video that I've posted, and I just watched the end of it. If you don't watch it, it's not crucial. However, it's a really cool video, and it kind of goes into some real life applications of what we see here in spectroscopy, like things like fireworks. So we see fireworks in different color fireworks because they're different elements. So every element is specific in a firework. So if you see a certain color, and that could be a copper element that's being ignited, or if you see another color, that could be strontium or sodium, those kind of things. Other things that we use this for is for road flares, the things that are on the side of the road if someone gets in a wreck and you need to like flag people down, that kind of thing. So all of this kind of has real life applications. We're not just igniting things because it's cool. So if you want to take a look at that, you really only have to focus on the end. If you don't, that's okay, because we're going to explain kind of what they said in a nutshell here. So how the flame test works is we need to get electrons excited. So currently, if you look on the left-hand side right here, electrons, so on this drawing, electrons are typically not excited. They are just kind of in their unexcited state, which just means they're in their normal ring that they would currently be in. But in order to get them excited, we need to give them energy. Just like you guys, in order to get excited for anything, you need to have some sort of energy source. So the electrons, what we do is we actually give it heat through the flame that we're going to do. If you use a spectrum tube, you can also give it heat, but that's not through flames. But either way, you're giving it heat and it's going to absorb that energy. The best way that I can explain it to you guys is, in order to give you energy, I could give you Mountain Dew and I could give you a ton of candy. And that's going to kind of do the same thing and emulate kind of what we're talking about with the electrons. So after the electrons had absorbed the energy, if you look to the right now, it's going to be in its excited state. All that means is it jumped. It jumped from the first ring to the second ring. And it doesn't matter necessarily the rings, but it just went farther away from the nucleus. And we call this its excited state. And just like you guys, if you have Mountain Dew and sugar and a ton of candy, you are going to be either jittery, hopping around, crazy, just like you would be like sometimes in class. Imagine that. All right. But now, just like you cannot stay at that excited state for a long time. You are going to crash. So what happens is you see on the right-hand side, the electron goes back to the unexcited state, goes back towards the nucleus, and it has to give off energy at that time. And when it gives off energy, it releases it in the form of light. And that's why we see different colors. Again, the same thing with you. You're going to crash, and you're going to give off some sort of energy. I think someone in one of my classes said it was a fart, which I think is more matter, but either way, it's kind of giving away the same idea. But you are going to release your energy. Now, different elements have different amounts of electrons that get them, or different amounts of energy that gets them excited. So some elements don't take much energy to get them excited, and some elements take a lot of energy, and depending on that will give us the color in which the flame appears. Just like teenagers versus a toddler, if I give a lollipop to a toddler, they think it's the awesomest thing in the world. If I give a lollipop to a teenager, they're like, what's the big deal? I'd rather have $100, right? So kind of the same thing is that no two elements have the same kind of energy needed to make its excited state known for their electrons. So what happens is when it goes from excited to unexcited and it releases that light, we see it as far as the flame test. So if you look at the flame test of zinc, the right-hand picture, that's what we see as the light coming off. What we can't see is the spectra. But if I actually took that color from that flame and we broke up all of the pigments in that, we would find that it looks like here. And that's what that orangish color is broken down. And if you take any element, you're not going to have a single flame that looks exactly alike. Also, the spectras are not alike because none of the spectras are alike. Again, we can't see the spectras, but we see the flame test or we see the flame, and we can get the spectras from other resources or if we had other equipment. Now, so what's the point of this? Before we do our flame test results, the big thing is no two elements are the same. They're all different because they all have different protons. And the protons change the physical and some chemical properties because protons also affect the electrons. If you have a proton, it's going to affect how many electrons you have. So every element has its own unique chemical, which includes spectras, and physical properties as well. And again, all comes back to the protons because that dictates most of the stuff within the atom. All right, so at this time, you're moving on to the next video, which is the flame test results. If you have questions, please ask. If you feel good, move on, and then you can look at the results.